There's so many definitions about cloud computing that it can actually get fairly confusing. So I wanted to find a definition that I thought was clear and concise about cloud computing. So here's one of the ones I found. It's information and services that are widely available yet reside in a location the public remains unaware of. Oh wait, that's for the public library. Oh, I'm sorry, I got that confused. You have some more different kinds of clouds. Software as a service, or SaaS, platform as a service, or PaaS, infrastructure as a service, or IaaS, application as a service, or never mind. How about this one? Do you know what this one is? SEA? Do you know? You're probably thinking maybe software as a service? Nope, tricked you. It's ass backwards. Now, here's one way to tell you're using cloud computing. Your program stops working because a coworker in the next cubicle is sucking up all the bandwidth watching an HD movie. So here's what you do. Turn up the volume on your computer all the way and play the following clip from the Rolling Stones. Now, what about virtualization? I found this interesting to find out about virtualization. The official Gartner definition is abstraction of IT resources in a way that masks the physical nature and boundaries of those resources. Now, if you're at all confused by that, here's a simpler way to think about it. Virtualization is actually just like chicken nuggets. Seriously, it's an abstraction of the look and taste of chicken that masks the physical nature and boundaries of the resources, right?
So, hello friends. So we're going to have this session. I was invited. It was nice. To talk about deploy, secure, and govern your applications on Azure, or, so I would like to call it, 5 awesome tips on running your app secure on Azure. So, in this presentation, we have Hasain.
That's me. Hi again.
Alshakarti.
We met yesterday.
Yeah, that's your Twitter handle. And you guys at Truesec, you always have this cool handle, like you working with security. So I was wondering this, because you're calling the wolf.
That's a long story.
That's a long story.
Whenever you're in trouble, I might be able to help you.
You might.
Yeah.
So that explains it. I don't have a cool handle like you, but for the sake of this presentation, I kind of thought I would invent something. So I would stick with the developer panda, maybe.
Yeah, why not?
I'll have the developer perspective on this session. So, I work at a company called AdLevel. I'm thrilled to be here today. I was actually allowed from my boss to be here. Everyone thought like, yeah, that's the guy. On paper, this is my boss, but in real life, this is actually my boss. My life is kind of run by a 3-year-old who knows everything. During this presentation, you will be able to participate. So we will ask you a couple of questions. So what you do is you pick your phone, and you just hit this URL in your browser on the phone, and enter this code. And you will be able to tag along. We will ask you some questions, and even people remotely. So you should see this question pop up in your phones. And we can try to hit you with an example question, which cloud you might use today. Oh, so this is pretty Microsoft-centric crowd. Sorry, Emil. Let's keep going also. Nice. Awesome.
Okay, good. we know how to set the stage.
Yeah. So we'll talk about briefly on the journey to the cloud, some perspective we had, moving applications over there, some pointers, what was working good, something that might be working not so good. And a lot of companies really want to strive and get to the cloud fast. So the developer are on board with it. As Emil said, a lot of developers embrace the cloud themselves and run all the things in there. But the organizations doesn't really keep up with the pace that the cloud promise on. And then you start with, you discuss with a lot of startups, and they're doing the opposite. They're really into trying the latest and greatest all the time, but that could be a pain as well. I actually heard about this new denial of service attack. They said denial of service based on you're out of money when you're running serverless. Like you only paid for this amount of compute, and then it's...
Yeah, you're just consuming all your resources.
Yeah.
Every penny in your bucket is gone.
And as a developer, the cloud is really promising because you just want to kick back and push code.
Yeah, that's something really gets very abstracted when you go to the cloud. You don't see that type of cost until, obviously, you get the bill. But
so the first tip is to really plan what kind of resources you're going to use. And really what not to use. So in this presentation, when you first asked me, I asked you, the first thing back was will there be virtual machines involved in this? And you said, no, you can run it on platform as a service. And I was like, okay, then I'm on board.
Yeah. So we're basically not going to focus anything about infrastructure as a service or running as VMs as such. So it's running application as a service and above.
Yeah.
Maybe serverless or,
So the thing is, when you just provision things, this in this sentence is machines, basically. So you want a simple basic, like a database server. You want to hit up an SQL server. You go to the marketplace and you just browse and you choose that server, deploy it, and then you get the bill 1 month later. And that's super expensive. And then you go no, we shouldn't use the cloud. It's really expensive. If we would run this internally, it would be much cheaper. So you go like this, oh man, the budget is gone. And then this guy shows up and gets you as well. That's pretty bad. So you really need to stick with the plan. And our plan, main focus was try to stay off virtual machines. And they trick you in Azure because you think you can go to the container services and spin them up. And then you realize no, wait, it's 5 machines. It's 3 with the cluster, and then you have 2 cluster managers, and you need to patch them as well. And you need to maintain that orchestrator framework if you're running Kubernetes or Swarm or whatever. So you think, I will use Service Fabric. That's Microsoft's orchestrator for it. And then you hit Service Fabric and spin it up. And then you get machines anyway.
Yeah. So we have to be very careful about when you select the different resources, just to understand what's in behind this. At the front end, it may be just an application visible for you, but at the back end, there may be a huge set of virtual machines running, which you must manage.
Yeah. So you really need to stick with a plan. And when somebody drifts from that plan, you kind of raise hell at the office, like you do when you're a developer panda. So I'm going to show you a bit about resources and how to plan a bunch of them. One thing that could be really helpful when starting to use Azure is to use the price calculator and set up things. So if you would provision a virtual machine, we just add it. You would select which region. It could be price differences between regions and what kind of type. So here you would typically select we need a database server on this one. And it will default to an enterprise edition always in Azure. You need to add some managed disk because you want it to be persistent in some way. And you can see that the cost is enormous. Yeah.
Speaking about regions, as you're showing that in this picture, There will be regions popping up or data centers popping up in regards to GDPR regulation requirements, etc., especially here in Europe. So if you're looking into that, please go there and look at the list of the regions or data centers available. The Dutch one, or the German one, is the first one that actually appeared now. It should be expected that we should have more of them appearing.
So what you can do, you could like scale it down. You could use a standard edition, and you could use less disk and a less heavily machine, and you do those customization, and you get down the cost to like a fairly amount of machine. And this is just for like a demo purposes. You have this machine, but every single time when you use platform as a service instead, it will be cheaper. So if you would throw like an SQL database and an app service on it instead, to compare apples and apples, we try to run it in the same region. And we could bump it up to like a standard, that was a production grade database, and also an app service plan in North Europe would be nice. We can also bump this up to basic, is pretty fine, but the standard. And that cost is always going to be cheaper. So it's always better to use the platform as a service.
We don't need to pay for the compute resources underneath. So we're just going to consume those compute resources we necessarily need to consume.
And when you deploy an app service, it's basically, when you choose an app service plan in Azure, it's basically a machine. It is a virtual machine. So when you have an app service, you could still run a lot of apps on that app service plan. So you don't have to manage one app service plan to one app service. So you can set up one app service plan and then host a lot of app services on them if you have APIs and front-end webs and whatnot. So it will be cheaper. So you select the kind of resources you want to have, and then you deploy them in Azure. And Azure has this notion of a resource group that you place all these resources into. And that's the big tip as well, is to manage those resource groups in some way. An effective way could be to use tags in regards to those resource groups and hit information that could be useful that you can automate upon as well. So it could be that you set the owner, if you have project codes, customer names you want to append. Expiration dates is a really useful one. When we do demos and stuff, we tend to stick an expiration date, and then we use Azure Automation to like clear up all the resources we don't use anymore, so we don't get billed on them.
Those tags will be used together with other things in the system. So whenever information is generated about these things, that will be tagged along with the same tagging system, so we can reuse that information further and on. Yeah,
exactly. So on a subscription basis that you set up, you can also trace on those tags. So if you have a project and you have something that spans a lot of resource groups, it's easy to do traceable things in regards to billing. Another neat thing that they have provided is the notion of policies in Azure. So you could set up, like for instance, at this place we set up a policy on GDPR locations. So when we deploy things when we try to deploy things, we can apply this policy and say that when you're trying to build these things, it can only run in Europe, for instance. Or you could say that when we deploy things, it must have tags in regards to a customer and expiration date, or so you can enforce those things on your resources as well, which is really useful.
So this will basically offload most of the tasks from the developers themselves. They can just go ahead, create whatever application APIs they need. They don't need to think about this as far as they stick into these definitions in terms of a policy.
And you have quite amount of like predefined policies that you can use and choose from, and then you can stick them into your subscription. And they will be enforced when people try to deploy things in the subscriptions. So that's pretty useful. Another useful thing that people have come up with when I try to do script that take things down is that you can also put locks on the resources. So if you have like really sensitive production things, you can append a lock to that resource group and then nothing can change it really until you remove the locks. So that's what's basically some first points about resource planning. And in the world of like DevOps, and when you choose to use like platform as a service things in your resources, in your plannings, a lot of operations people, like Emil also mentioned, go like this, because you kind of abstract 2 pages from their resume, like how to build a load balancer, how to use a lot of network, how to use DNS management things. And when you use a platform service, you really have like DNS endpoints. That's basically what you use against to communicate, and then you secure that kind of communication. That could be internal DNS names in Azure, so it doesn't matter exposely. So a lot of ops people go like this and like, well, we don't know what we're going to do with this, and then they hand it over to the developers themselves to handle this. And they don't really care. They just think that, oh, it's magic. I got a slider to have more instances of this thing. So they're happy campers. So that's the first thing, to plan with resources. And as an operation perspective, it'd be really good to learn these things, like test app just to deploy it and see how it works and how the load balancer works and stuff. Because it's a pain in the long run for developers also to manage these things. If you take Docker, for instance, if you run Docker instances and you need to do things with images and you need to script things, add runtime things, it could be a bit of a pain for developers to handle all that. So it's still a valid operation role, so to speak, even if you go cloud.
Yeah. So probably most organizations need to put some guidelines for the developers, what kind of resources to rely on.
Yeah.
That's, if you're putting in web services in place, please use a web application firewall, or we might enforce that using some sort of expected configuration setup, etc. So we have to then conduct monitoring. We have to go back and check what the developers are actually deploying.
So my next tip when moving over to cloud is to manage secrets. And I think we have a question on this one. So on the phones that you have, you should be hit by a new question. So I have never checked in a secret in source control. And that could also be like, if you're a script guy, you have never ever had a password in a script or placed it somewhere bad, like a public share or... Oh my God, Hasain, can you see we have like 10% of liars in the room?
Well, maybe the source control definition should be extended to file shares, etc., laying around wherever code is found.
Yeah.
Not necessarily in GitHub only.
No, but that's really bad.
Yeah.
Really, really bad. So that was the next thing. When you're developing things, you tend to have a lot of things in web config files or configuration files. So on this machine, we set up application settings. So this is running on the latest and greatest ASP.NET Core. And we have an app settings JSON file, which basically has all the configurations that we want to have in the application. So we have a secret that we have put inside of this app settings file, but you could do overrides, so it's just key values that you have in the configuration files. So in Visual Studio, you could have something called manage secrets. That is really in regards to the developer, and that's not stored with the code. It's extracted in the user profile and protected by the user settings. And you could place the same values in there. So if you have kind of secrets, you're using developer API keys or whatever, you could put them in this location instead. And when you run the application, it will read them from your application. So this is running locally. I can see when I hit the runtime that this is from the secret JSON instead, that it reads up this information.
Yeah.
And when you deploy it to Azure, those secrets won't be deployed.
Won't follow with that, yeah.
No, so you need to have those secrets somewhere else when you deploy them in Azure. So if you're using an app service plan, you could use them and stick them into the app service themselves. So if we look at the resource around this app service,
so that's yet another best practice or security practice you need to recommend or make sure your developers are following. Not to have secrets within the application that are deployed together with the application to the platform.
Exactly. So in this case, we have that secret set up in the app service plan instead. So you could have it over here.
Yeah.
So if we look at the same application running in Azure websites, we can see that we have this app settings, this secret from the app settings part.
So you, as a developer, can still continue and validate and use that secret locally, and then once you push your application to the cloud service, it will get other values from the locally defined variables, right?
Yeah. But you could also, like now I'm logged in, so you have protected secrets as well. So in this case, when I'm logged in and try to hit this, I get the secrets from Key Vault.
So now it's depending on the user logged in and access to Key Vault.
Yeah, so if you don't want to have it stuck in the application service plan and replicated with the application service, you could actually extract it from the application service as well. And when you set up application services to run in Azure, you can basically pin a principal on them. Like, for instance, if you have a local application you're running on your on-prem environment, you have it on Windows credentials that read out secrets.
So that principle is actually an Azure Active Directory principle. That's a user ID in Azure Active Directory.
Yeah. So this is pretty new. It's like 2 weeks ago. They introduced this managed service identity that you can run on the app service plan and different app services that you have in Azure. And then in Key Vault, it's basically a protected container for applications. You can grant this principal permissions. So you just add that principal in Key Vault. And also you could add managed users that you want to administrate the Key Vault as well. And then you stick your secrets in Key Vault instead and delegate those permissions. So here we have the secret added to Key Vault, and we have, well, I can show the value down here, and you could have like rolling configurations and so on in the Key Vault side. And you can store certificates in Key Vault as well, and keys in Key Vault. So it's pretty good service to use, and it's really cheap, like cents.
And this identity management is not just for this purpose. It actually stretches even for access across applications, across services. When you're accessing your database, for instance, you can use that Azure identity to access the database. Instead of using stored secrets.
Exactly.
In classic ways.
So that's a good thing when you move into the cloud to manage those secrets. The next thing we had a big challenge to rewrite about things around is the identity things. Because when you run things on-prem, you kind of lazy set up Windows authentication and constrained delegation, for instance.
Yeah, or most of the times actually NTLM.
Yeah, challenge response.
Not even Kerberos-based.
And then you hit up your application, you get a Windows principal in your application, and then you use like the role-based system that's been there forever, and it's awful. So we have another question in regards to identities. And it's actually how many who uses Azure Active Directory today. So it's a fair amount of people who actually use Azure Active Directory, either in regards to they have Office 365 and have been moving like the backend services to Azure. Or they have an Azure subscription. If you have an Azure subscription, you actually have an Azure Active Directory. You can't live without it. But when you have an Azure Active Directory, it's fairly simple to integrate your application and do the plumbing and replace the identity system that you had on premise in regards to use it in Azure Active Directory. So what we needed to do was to replace the Windows Auth integration to the application in regards to OpenID Connect and OAuth 2.0, which OpenID Connect actually runs on.
So just to explain this very simply, the OpenID Connect is an extension to OAuth 2.0 because the OAuth protocol doesn't handle authentication. So that's what OpenID Connect will do for you. So that's the extension part of it. And it's adding much more flexibility to the OAuth protocol. So we can have other sorts of claims going on here using the OpenID Connect structures.
Yeah. So in this application that we developed for this session, we actually use an Azure Active Directory B2C container, which is basically if you don't want to run identity system in your application, you can hit up an Azure AD for end user provisioning and kind of hide it behind your application. So when you have a sign up pane, or they can just type in their email address, password, as you normally do in an application, or chain it to a backend service like you're using Google or Facebook. And actually, Microsoft will store that and handle that identity system for you. So you don't have to have it stored in your application.
Or if you want to chain that to your on-premises Active Directory, that's perfectly working as well.
Yeah, exactly. So if you have set up integration to replication, you can use that Azure Active Directory instead. So what you do is that you register your applications and your APIs in Azure Active Directory with an application ID. And then you can set up secrets for those applications as well. And it's actually how the OpenID Connect standard works. It has different kind of flows. Don't go into specifics, but we're using a hybrid flow. So basically, we log in, the application signs you in. If they do a challenge response, you get an ID token back. And then you can have an authorization code back, which actually the application can do a delegated request on behalf of the user to get an access token. And that access token is kind of like Kerberos tickets.
Very similar, yes.
Yeah. So it's basically using that ticket under the cover to consume and use APIs. And a big announcement Microsoft did during Ignite, I don't know why they announced it, because it has been exposed earlier. It was the Graph API that they have. And that's actually a way that you could use those access tokens you authenticate and get with your ticket in your application to ask Microsoft services with the access token to get information from Azure Active Directory, for instance. So you could add that, those API calls in your application. And what it looks like when you authenticate, so I signed in to this application, I was redirected to the Azure AD B2C and then back. Sorry, this one. And I can see that I get a fair amount of claims in those tickets. So claims are basically key values that you head off. And you can see I got this ID token back with a URL rewrite. And these are signed, but they are not protected in any way.
No.
So if you have something like GVT.io, you can just stick in the tokens that you get. It's a JSON token. They call them JOT.
Yeah.
So JSON web token, basically. And they have a header saying which algorithm they use for signing. And you have the key values in the payload. And then the signing at the bottom of the ticket.
So one could wonder, how come these things are sent in clear text? Why aren't they encrypted? Or what is the protection mechanism behind that? Well, all the transactions we perform should be performed on or using TLS. So TLS is the thing to protect all the communications going on. So we don't need necessarily to encrypt every single token we send. They are cryptographically protected with digital signatures, so we don't doubt about that. We don't need to cover that in any other ways, because they are protecting themselves. But we don't need to bother about privacy because TLS is taking care about that. Yeah.
And you can stick in a lot of claims and extend them in the payload. So in Azure Active Directory, you basically can hit tick boxes like, I want a friendly name, office, this, and then you get it back to your application. And then the new thing in ASP.NET or the .NET runtime, you could build something like policies. So you can see, based on these kind of claims, I can build an authorization policy.
And give them the role to access something or do something.
Exactly. So basically, you could get one extension of how did the user sign in. And you can see it, which first used the username, password, and the multi-factor authentication token in some way. And then you could have that policy applied to the application. Like, oh, and then we use and show you the admin parts of this application, for instance.
This part in total, the handling the claims and the identity and all of the transaction we're showing, you can actually do the same thing on premises. There is no difference at all. You just use your ADFS services or other type of claim providers and authorization services providers. So once you move your application to the cloud, then you just exchange that with the Azure Active Directory components.
Yeah. And they are kind of different, the access token and the ID token. So when you have logged in, the application requested the access token for you. Those are more short-lived. And the new thing in Azure Active Directory, in the 2.0 endpoint, they use these really for like every kind of request you do. So you can build them dynamically, these access tokens. And they use something called a scope. So you can change and plumb different things into the scope of these kind of tickets. So in this regards, I have only read access at scope, for instance. And Microsoft have those scopes for the Graph API as well. So you just hit them with it that you need an access token to consume the Graph API. But it's really useful and it's really important to learn this authentication authorization system when you're building web apps.
We have some, to add to this, there has been some recently released features for the Azure Active Directory authentication. We have something called the pass-through authentication, which basically you just provide username, password to the Azure sign-in services that will be validated with your local Active Directory, so if you're doing pass-through of the credentials. And we do have a simplified single sign-on experience using Kerberos, so you can use Kerberos to authenticate to Azure services. That has been released for public usage as well, just recently. So you don't need to synchronize passwords or store passwords in Azure at all. You can just use Kerberos single sign-on towards Azure services.
So the next part, you get your authorization identity system in place. You selected the resources you're going to run this on. You will start to eventually load in data and have in that application to some extent. And this was funny because at the Ignite conference, they were really proud of this Azure SQL protected parts that they have, and they had this post to the Verizon data breach investigation report that says that 75% perpetrated by outsiders, like basically someone trying to hack your application, while 25% involved internal actors. It could be like sloppy configurations, or the user account had been hacked or somewhat. But it was funny because when they were running this presentation on Azure, this happened. So the Verizon themselves had used Amazon as a cloud, and they were storing log files totally unprotected, and they had pretty sensitive information in those log files. So you really need to have control of your data when you're using it in a cloud service anyway, and it's the same when you're using it on-prem.
And it's not just about data in the application or wherever you store it when you control it by the application. All other sorts of data is equally important, as this case shows. I mean, server logs or application insight logs or something like that.
Yeah. So we had another question in regards to this, and it's on which level, where do you encrypt today? What kind of data do you protect today? Like disk volumes, you're using BitLocker maybe, or file system, EFS, and so on. Maybe in databases, using encrypted technologies. An application level, you're doing encryption in application. a fair amount that have as application level. That's surprisingly.
Well, it
pretty even Steven.
Depends how you define application level.
True, true. Do you protect it in code? Oh, no. Ooh.
Or in transport.
Or in transport. Yeah, that's true.
Interesting. A lot of people are obviously concerning about data at rest on disk, so at least at that level.
Yeah.
And some more on files, particular files. Maybe data content encryption as such, like RMS, IRM type of technology.
Yeah. So in Azure, when you hit up an SQL database, they are using per default something called transparent data encryption. And that's just a tick box. It's always on.
Yeah.
And I'm not going to steal a thunder from the next presentation because they will talk more about encrypting things when running an application. But this is basically turned on. And then you have auditing and threat detection in the service as well. So you can just light that up. You get notified when it detects, like you have SQL injections and so on. And Microsoft has actually a really good application, a test application that you can run to test and try this out. And it can be useful for more than just the database and the data protection things. It could be used in the web application firewall tests as well, because they have a really neat search box here for patients. And they have some SQL hints how you should search in that one, which are basically SQL injections. So it's pretty fun to try out.
Anybody thinks or have seen these things in your in-house developed applications? Like, this is how you do fast searches in your databases?
Yeah. So when you have the application set up in SQL, you have transparent data encryption. It encrypts everything and kind of stores the secrets with the database. But you can also use something called always encrypt, so you can protect different parts inside of the application. So with this example, I'm running this as a DBO, so I can do actually whatever I want to with this database. But I can't see what the SSN number is in this table. And I can't even see what the birth date is in this table. So it's obfuscated for the DBAs. And those things using the always encrypt technology. So it's basically an encryption key that you use from column-based, and then you have a column master key that protects that encryption key. And when you look at the column master key that you need to run, it's actually stored also as a secret in Key Vault.
In the Key Vault. So an application with the proper access to that Key Vault can extract the key and then...
Exactly. So it's actually managed over at the application side. Yeah. So this is actually the application, and this application runs, and it can see the SSN number and birth date. So that's a technology that you can use, and then you can stick that secrets together with the application and have the runtime managed.
And in terms of the efforts you need to put in your application to make this happen, this is all integrated in the APIs and the calls?
Yeah, exactly. So it's appended to the database connection handling in the application layer. And you have different other neat things in Azure SQL as well. So you could use masking and add that as a function to execute on different parts. And we hit the application again, we see that the last name here has been masked. So you do those kind of filtering in the database side. When you run it on Azure as well, you get tips on what kind of dynamic data masking you should protect, what could be sensitive information. So when you run it in the platform service, it says like, oh, in these tables, you have an email confirmation, you have a password hash or something that maybe should be masked. Nobody should read it in the application layer.
Yeah, and of course we should consider the other effects it might have on indexing, relational or relation definition between different tables, other components within the database, etc.
Yeah.
Right?
And the last thing that you have in Azure SQL as well to protect against kind of SQL injection attacks and so, it's something called row-level security, that you append query things to the extension when people doing the database connection. It's actually running in the kind of a user runtime, so you can't expose more data than the user has access to.
Yeah.
And that's really useful as well. So that was the database part. So you put the databases in there, and you have it set up, and you kind of need to figure out what you need to encrypt in the database and protect, what kind of masking you need to run. The last thing that you want to do on the application is to hit with tracing. Like, you want to see when it fails, how to build it resilient, how to scale it, and how to use it effectively. So I think we had a question in regards to this as well. And it's if you're using some kind of logging solution today. So in Microsoft world, that might be OMS. I realized I didn't have like syslog servers. That's probably others.
Yeah, that would be others, or event logging, or
some people don't have logging at all. If you're running ELK, no OMS. So when you set up the application in Azure, you have some meaningful data that you get when you're running the platform as a service. So if you look at the resource group and hit it with an app service instance, you will have like basic monitoring of application. You could see that it has like 500 errors, some server internal errors that might happen. You have data in, data out, number of requests, average response time. These are really good metrics. You could hook up automation events, like scale out, scale down, in regards to these basic metrics. But they don't really tell you more granular control, the specifics of the errors that you do hit in your application runtimes. So you can see that you have kind of like 500 errors, how many you have in the time frame. But something really useful to add to your application when you're running in Azure is something called Application Insights. And that's a bit more granular. You could, it's easy to set up in an application. You just basically say you have a connected service, add it, and it's a library which adds Application Insights as an instance, and then it's have a telemetry key sending off information to Azure. I bet a lot of people seen it when they install application. Just from Microsoft these days, you get a question like, this application is recording everything you do. It will give them passwords, email, everything. Is that okay? Yes. That's Application Insights at play. And what it does, it adds a library to your application. And it's pretty transparent. I think it's just running in some kind of like reflection mode, what you have. So you don't really have to decorate your code with it. But it will catch all the exceptions that your code throws. And when you add Application Insights to your resources in your resource group and pin it to an application, you will actually get, you will get more granular information. And you could use other things in Application Insight as well. So it has like a dynamic application map that it detects as well. So if your application has dependencies, you're using a lot of APIs, database connections, and so on, it will dynamically build an application map for you to see all those dependencies and where resource and executions might take a long time.
And that might be a very useful way to figure out a baseline for your application. I mean, if you've been running it for a time, then you can go back to this map and look, what do we actually communicate with? How much do we do that? And then you can go back and look for anomalies and odd things that might occur.
Yeah, and it's pretty useful. You can see how the response time is. You can see all the exceptions, and you can drill into the exceptions. So you can get more fine-grained information about what kind of controller, what call stack was hitting this, and you can see the top execution types that you have, and you can see the exception details without really having to write any code extension for it.
So all that information is obviously hosted on the Azure services. Is it possible to forward that information somewhere else if I want to consume it on my own systems?
You could. It has a log analytics side. The seamless integration part is to OMS. So you basically, if you're running it in the cloud, you don't want to, because every data out from the cloud you pay for.
There's a cost, yes.
So that's why you don't want to use like VPN networks and so on, because those will drive cost. So it's better to use it in OMS. So you hit it up in the OMS, and then you can offload the application insight into OMS, where you probably extend and have log shipping for other things in Azure as well.
So we can start correlating with maybe other resources, other resource groups, other applications, etc.
Exactly. And another neat thing they have in Application Insight is, not the application map. It's something called availability. So you could build availability probing on your application. And the easiest one to set up is just like ping them. Is it up or down? And you can head up which endpoints from where those should be monitored, from which sites. So they have a shitload of sites that you can pick from, and they will try to ping your application and see if it's live. And then you can also, if you have Visual Studio, you can build transaction logs in them as well. Like you have a login, need to do something. So it's basically what you had in SCOM before. You could use the kind of same metrics and do things in regards to application insights. And as we mentioned, you can have it in Operations Management Suite integrated as well.
Or you could probably forward that to an event bucket within Azure. I mean, you can use eventing handling systems in
So on a lot of places, when you are in Azure, you will see that you have like a log analytics extension somewhere in the pane on the resources that you provision. So in Operations Management Suite, they have a lot of things called solutions. So you just add a solution for application insights and other things, platform service-wise, if you're running Azure SQL and for the subscription itself. So you have the traceability and log for everything that's going on in your subscription and inside your applications. And the same kind of information is offloaded to from application insights to OMS. And OMS is a really, really, really powerful log analytics framework. So you basically hit that with JSON format data, and you can build whatever you want on top of that, logic-wise. So it's pretty useful.
Another type of logs we might be interested in consuming is the diagnostics logging for resources in Azure as such. This is not within the applications. You don't need to integrate, or you're not integrating that within your applications. These are logs brought to you from the underlying different tiers of underlying systems, like the operating system, the different stacks underneath, or wherever your application is running, if it's running serverless or with server components, etc. So please look into that as well, and then stream that information. If you're running OMS, stream that to OMS, or you can just stream it to storage in Azure, and then you can consume that either on Azure or outside of it.
Exactly. And you can hit this up on all the different resources that you have, so it's pretty useful. So that was like the short thing about the logging and the tracing. And to summarize this session, those 5 tips that we were running was basically this. So plan your resources, try to use something else than virtual machines, because those will be a hassle to manage in the long run.
And do care about delegation, do care about what the developers are able to stand up in terms of and select for type of resources.
Yeah, and when you use platform as a service, it's much easier to scale them without dependencies on networks and so on. The next thing was to store the secrets away from code. Use something like Key Vault. It's really useful. And you can stick certificates and everything that you need for your application runtimes.
So if you happen to have requirements to store those secrets on your own devices, you can have dedicated HSM devices as well. There are shared HSM devices, of course, but you can still have dedicated ones in Azure as well. You can generate the keys on your own and push them to Azure. Then they will not be exportable in different ways depending on how you generate the keys, etc. So if you have specific requirements on how to deal with those secrets, there are different flavors of that, of course.
And then, of course, it was to use a modern authentication system for web. OpenID Connect, OAuth 2.0. Learn that specification, read up on the RFC, see how the implementation is on Microsoft. If you don't want to roll it with Microsoft, you can also use to roll it in code. It's something called Identity Server. It's really useful.
Or rely on ADFS. That's ADFS version 2016. Delivers OpenID Connect compatibility.
Yeah, or you could use something like OAuth, OAuth 0 or other vendor providers, like software as a service.
Even if you're not moving your applications to the cloud today, start conducting this even locally when you're running your application on premises. So start doing federation instead of doing Windows integrated authentication.
The next thing was to secure your data when needed. That's a kind of a cliffhanger for the next session. They will probably tell you when you need it. But in the Azure SQL service, it's really simple to start using the components they have. They have some minor shortcomings. The next session will also discuss those things, I guess. And also protect like file stores, of course. So if your application running file stores, storage, and somehow you can protect that as well, different ways. And the last thing is to trace on everything, like use the built-in traceability that is in the platform services. Use something like Application Insights. It's really cheap. I think you have like 1 gigabyte of data for free, and then it's like also pennies for running it. And it's really, really useful. It also has usability tracing, like you can see how often things are used in your application. So you got like kind of a Google Analytics part from it as well.
And don't forget to collect the diagnostics logs from the system surrounding your application.
Exactly. So just because you have it in your application, you might also want to have it traceability and all audit logs on, for instance, Key Vault. Who is accessing the keys, when, why. And Key Vault, you could use Key Vault when you develop as well. So if you're using Visual Studio and you need to get the secrets from Key Vault, you need to have the Azure CLI installed on your machine and has it running and authenticated. That will use your personal principal that you set up in Visual Studio to access the Key Vault. So you could use Key Vault in development as well. So those were the 5 tips for this session. Would like to thank you for this session. And remember, cloud isn't magic, if you can think it is. It's just easier to use the platform services and learn what they are, how they are composed, and what they do, and get everyone on board with it.
And don't forget about putting together your guidelines, because that's the way you will govern those operations. That's the important piece in it.
Do you have session evaluations?
Yes.
You read?
Yes, of course we do.
So please, please, please evaluate this session.
Now what am I going to say?
Oh.
That's his part.
Sorry, stealing your fun.
Yeah.
Thank you, guys.
Thanks.
Hasain and Rickard.